The Fokker 50 is equipped with a weather radar, an altitude entry and exit alerting system, a ground proximity warning system, 2 ATC transponders, and a flight data recorder. These systems provide additional information to the pilots, air traffic control, and other aircraft internal systems. The Fokker 50 is fitted with a single weather radar installation. The primary purpose of the radar is to detect weather and present the pilots with a representation of the intensity of rainfall ahead of the aircraft. The secondary purpose is for ground mapping. This function is used for navigation. The weather radar display is presented on the captain and first officer's navigation displays in map and arc modes. The weather radar comprises a transmitter-receiver unit and antenna mounted inside the radome. The antenna, and therefore the display, is stabilized in pitch and roll to the horizontal by AHARS-1. The displays are switched on and off and brightness controlled by the inner display dimmer knob on the EFIS control panel. The weather radar control panel is located at the front of the pedestal. The controls on the weather radar control panel comprise 6 push buttons, 2 rotary control knobs, and a rotary switch. Press the up arrow push button to observe its effect. The push button marked with an up arrow increases the range of the display. The ranges of the radar are selectable from 5 miles to 300 miles. The range marker is halfway to the maximum range. The example shows a range of 100 miles with the marker at 50 miles. The ranges of the radar are selectable from 5 miles to 300 miles. Press the RCT push button to observe the effect on the radar. When RCT is selected, a blue area appears on the display behind any intense weather returns. Pilots should be aware that in this blue area, the radar signal is reduced in strength and only very heavy precipitation will be detected. If rain is detected, it appears magenta on the display. RCT selection is enunciated in green. With RCT selected, but with the display not showing any strong weather returns, the blue area is not displayed, although the RCT facility is operating. Now select the stabilization push button. You will recall that the weather radar scanner is stabilized to the horizontal. The stabilization can be turned off by pressing the stab push button. The amber off annunciation above the button illuminates to indicate an unstabilized display. The TGT push button enables the target facility of the weather radar. The annunciation of this selection is TGT on the display. With the target facility selected, the radar will detect heavy precipitation beyond the range selected on the display, in this case 100 miles. The TGT annunciation on the display turns from green to amber when precipitation is detected. The target facility only operates within a sector 15 degrees wide on the center line of the scan. The maximum radar range on which the target facility operates is 200 miles. At this range, precipitation can be detected to a range of 250 miles. The normal scan angle of the radar is 120 degrees. Pressing the sector push button restricts the scan angle of the antenna to 60 degrees. Because the scanner is operating over a smaller angle, the rate of scan is increased and the display is updated at approximately twice the normal rate. There is no annunciation of the sector push-button selection other than the narrow weather radar scan on the navigation display. To check your understanding of the weather radar so far, what is the meaning of the blue area behind the weather? Yes. Which of the descriptions best fits the display on the screen? That's right. The gain control can be pulled out from the panel in addition to being rotated. Under normal circumstances, the gain control is left pushed in. In this position, the radar sets the receiver gain control automatically. Pulling out the knob enables the gain to be varied from minimum to maximum by rotation. The annunciation is an amber VAR on the ND. Operation of the target or RCT push buttons cancels manual gain selection and the radar sets optimum gain for the function selected. The tilt control elevates or depresses the scanner angle 15 degrees up or down from the horizontal. If the scanner stabilization is disabled with the stab push button, the scanner is moved in relation to the aircraft center line. When the function selector is at off, power is removed from the system. Provided that the EFIS control panel weather radar knob is not selected to off, the amber annunciation WX is displayed on the ND. Turn the weather radar to standby. In standby, power is applied to the system, but the scanner is stationary and tilted up, and there is no power to the transmitter. A green standby annunciator is displayed on the navigation display. With the function knob at the WX position, the weather radar is fully operational. The displays and push-button selections now operate normally. Now select the ground mapping mode. In order to use the ground mapping mode effectively, the scanner should be tilted down using the tilt knob. The display uses different colors in the ground mapping mode. This will be covered in more detail later. Selecting the FP or flight plan position on the radar function selector puts the weather radar display to standby in order to permit the display of navigation data at the ND. The test position and system test is covered later in the system operations section of this module. In a weather mode, the display uses 4 colors to represent the intensity of the rainfall. The colors are green, which shows light rain, yellow, which shows moderate rain, red, which represents heavy rain, and magenta, which shows intense rainfall. The ground mapping mode uses 3 colors to represent topographical features. These are cyan, yellow, and magenta. The radar selects the colors in order to give the pilots a ground mapping display which cannot be mistaken for a weather display. The weather radar display has 3 annunciation lines on the left. The top line indicates the selection of the target function. When the TGT annunciation is green, no out-of-range weather is being detected. You will recall that an amber target annunciation indicates that weather has been detected beyond the selected display range. The variable gain annunciator also appears on the top line. Selection of the target or RCT functions overrides variable gain annunciation, and TGT will replace VAR if both target and variable gain are selected. You will recall that the weather radar on annunciation appears on the second line. This annunciation can be either green if the radar is on, or amber if the radar is off. Other line 2 annunciations are wait, which is displayed after switch on and the system is warming up, and standby when the function selector is set to standby. The RCT annunciation replaces the WX annunciation when RCT is selected on the control panel. In the ground mapping mode, GMAP is annunciated. During system test, the test pattern is displayed and the annunciation is test. If the system fails, the second line annunciation is fail. The third annunciator line shows the scanner tilt angle from plus 15 degrees to minus 15 degrees. Which of the answers best describes the following annunciations? The top line has an amber VAR, the middle line has a green RCT, and the bottom line has plus 3 degrees. Please touch the highlighted area. Yes. With the weather radar selected to standby, there is no radar display on the ND. Now turn the radar on. The operating range can now be selected. In map mode, this is dependent on navigation requirements. In arc mode, the radar range is set to give good weather coverage ahead of the aircraft. You will remember that target can be selected to indicate the presence of significant weather returns beyond the range selected, and that RCT indicates areas of degraded radar performance. Selecting the ground mapping mode and selecting tilt down for the antenna provides a radar map of the ground. The presentation of the information depends on the type of terrain over which the aircraft is flying. In most circumstances, the display is suitable to be used for navigation purposes in conjunction with experience of the route or with a map. The scanner may be tilted during flight to obtain the best representation of the weather ahead of the aircraft or for ground mapping. Move the scanner fully down. A depressed scanner will pick up ground returns in addition to weather returns. You will recall that if the antenna stabilization is switched off, the antenna is aligned with the center line of the aircraft. When the aircraft pitches down, the display shows ground returns. When banking, the wing low side of the display may show ground returns, depending on the angle of bank. You will recall that pressing the sector push button restricts the scan angle to 60 degrees. With sector selected, the display is updated at approximately twice the rate of the normal 120-degree display. You will recall that the display has 4 different colors which indicate the intensity of the precipitation ahead of the aircraft. Depending on factors such as range selected, pilots would normally change course to avoid the areas of heaviest rainfall. As stated earlier, the ground mapping display uses cyan, yellow and magenta to provide a representation of the ground ahead of the aircraft. Interpretation of the display requires a familiarity with local topography in comparison with the ground mapping display. When test is selected, the radar produces a standard multicolored display. Some of the colors are dependent on switch selections. When target is not selected, the narrow segment at the top of the display is black. When target is selected, the segment is red. Note that if the target facility is operating during the test and weather beyond the selected range is detected, the TGT annunciation turns yellow, not amber. With RCT not selected, the outer arc of the display is black, the second arc contains noise, and the third arc is also black. With the RCT facility selected, the 3 segments show a different display. The outer arc is blue, the second arc displays magenta noise, and the third arc is blue. If AHARS 1 fails, the scanner is no longer supplied with pitch and roll stabilization. By switching off the stabilization using the stab push button, the antenna will center its scan on the aircraft center line. With stabilization off, the antenna scan and the display follows aircraft pitch and roll movements. The weather radar display is switched on and its brightness adjusted at the EFIS control panel. The weather radar is controlled using the weather radar control panel located at the front end of the pedestal. The scanner is stabilized to the horizontal using an output from AHARS 1. The radar test facility is activated by rotating the function select knob to the test position. The Fokker 50 is fitted with a single ground proximity warning system. The function of the system is to monitor the flight path and position of the aircraft relative to the ground. The operating range of the GPW system is 50 feet to 2,450 feet radio altitude. The ground proximity warning system does not operate through the integrated alerting system. The pilot is presented with both audio and visual warnings if the aircraft is flown into a potentially dangerous situation within the altitude range of the equipment. The warnings continue until positive action is taken to correct the situation. When corrective action has been taken by the pilot, the warnings cease. This is usually when a climb is initiated or when the aircraft configuration is corrected. The principal input to the ground proximity system is the radio altimeter. The mode of operation of the system is modified by inputs from the flap and gear position. Other inputs which are required for full operation of the system include stall warning, decision height, glide slope information, and barometric rate and altitude information. Pilot input switches are located on the captain's main instrument panel. They include a system test button, a flap position override switch, and a glide slope warning inhibit button. The overhead panel general switching panel has a fault light and ground proximity off push button. The fault light is triggered by the IAU. The ground proximity audio warnings are presented using two methods. There is a dedicated loudspeaker in the flight deck roof and an input to the integrated audio system. The audio system routes the warnings into the pilot's headsets. The warnings will also be heard if either of the pilots has selected an audio system loudspeaker. There are two sets of visual warnings, one for each pilot, mounted on the main instrument panel. These warnings are a red GPWS annunciator light and an amber glide slope light. Earlier in this module, you learnt that the fault light for the ground proximity warning is on the general switch panel. This light illuminates when the system internal test detects a fault. A GPWS fault causes a level 1 alert. The fault light is located in a guarded and sealed push button. In the event of a fault, the switch cover is lifted and the system is switched off. The controls that are available for normal operation of the ground proximity system are located on the captain's main instrument panel. The test button initiates a system test. The guarded flap override switch enables the pilot to inhibit the warning that is generated on approach when less than 25 degrees of flap have been selected. The glide slope warning inhibit switch removes the Mode 5 warning generated when an ILS approach is made below the glide slope. In order to test your understanding of the parts of the ground proximity system covered so far, locate the box which represents the principal input to the system. The radio altimeter is the principal input to the GPWS. What is the vertical operating range of the GPWS? Yes. The ground proximity warning system has 6 modes of operation. 5 of these warning modes are concerned with generating warnings, and 1 is an information mode. Mode 1 detects excessive barometric sink rate. This is achieved by comparing radio altitude with barometric rate of descent. If the rate of descent is too high, the audio warning sink rate is
sink rate, sink rate.
If no corrective action is taken by the pilot, the warning changes to
Pull up, pull up, pull up, pull up.
The warning envelope for the Mode 1 alert shows how the sink rate and pull-up areas are defined. The diagram shows the relationship between the causes and warnings of the Mode 1 alert mode. Mode 2A detects an excessive rate of terrain closure. The GPWS compares the actual radio altitude with the rate of change of radio altitude. The initial warning for Mode 2A is
terrain, terrain.
After 1.4 seconds, if no recovery has been started, the warning changes to
Pull up, pull up, pull up, pull up.
As corrective action takes the aircraft out of the warning envelope, the audio warning reverts to terrain. After the aircraft has climbed 300 feet, the warning stops. Mode 2B is operational when the flaps are set to land at 22 degrees or more. This mode operates between 789 and 200 feet, and no altitude gain is necessary. Below 700 feet, with gear down, the whoop-whoop pull-up warning is disabled. The flap override switch, when set to off, simulates flaps 22 degrees or more. Consult the diagram for a summary of the Mode 2 warning. The GPWS Mode 3 detects a loss of altitude after takeoff. The detection system compares actual altitude with a loss of altitude. The warning is
Don't sink, don't sink, don't sink, don't sink.
If the system detects a descent after takeoff, it memorizes the altitude at which this happened. After descending 10% of the memorized altitude, the warning is presented. The example shows a 60 feet altitude loss from an initial altitude of 600 feet. Consult the diagram for a summary of the Mode 3 warning. The Mode 4 warning is presented when there is an inadvertent proximity to the ground in the wrong aircraft configuration when in approach mode. 3 warnings are presented, depending on whether the gear or the flaps are not extended. These are
Too low, gear, too low, gear, too low, gear, too low, flap, too low, flap, too low, flap, too low, flap, too low, terrain, too low, terrain.
The diagram shows the Mode 4 warning envelope for approach with gear not down. The diagram shows the altitude and speed constraints for the Mode 4 no flaps envelope. Study the diagram for a summary of the Mode 4 gear and flap warnings. Note that Modes 1 to 4 cause the illumination of the GPWS warning lights on the main instrument panel. The table summarizes the details of the Mode 1 to 4 warnings. Which of the choices shown best describes the Mode 1 section. Please touch the highlighted area. Yes. Which of the causes shown best describes? Please touch the highlighted. That's right. The Mode 5 warning only operates during an ILS approach and is triggered by the glide slope receiver selected at the flight mode panel. A warning is presented when the aircraft is more than 1.3 dots below the glide slope and only operates below 1,000 feet radio altitude. The warning is
Glide slope. Glide slope.
below 300 feet and with more than 2 dots deviation. The warning increases in loudness and frequency.
Glide slope. Glide slope. Glide slope.
You can now study the relationship between the Mode 5 warnings. The Mode 6 warning is for pilot information. As the aircraft descends through decision height, the pilots hear
Minimums. Minimums.
Use the diagram to revise all 6 warning modes of the ground proximity system. All warnings generated by the ground proximity system are inhibited when the stall warning is operating. This is to prevent pilots attempting to pull up whilst the stick shaker is in operation. You will recall that the flap override switch is located on the captain's main instrument panel. This switch suppresses the Mode 4 warning, too low flaps, during approaches made with a flap setting of less than 22 degrees. The glide slope warning inhibit switch suppresses the Mode 5 glide slope warning during a deliberate approach below the glide slope. Mode 5 warnings can only be cancelled in the soft warning envelope. The ground proximity test button is located on the captain's main instrument panel. The test can only be conducted below 50 feet or above 1,000 feet radio altitude. There is a minor difference in the test results depending on whether the test is conducted on the ground or in the air. Test the GPWS on the ground.
Glide slope. Glide slope. Whoa, up. Whoa, up. Whoa, up. Whoa, up.
The test on the ground presents the fault GPWS and glide slope lights and a level 1 chime. This is followed by a glide slope announcement and the pull-up warning repeated 4 or 5 times. The fault light remains illuminated until the button is released. When conducted in the air, the test gives the same results except that the whoop-whoop pull-up audio warning continues until the test button is released. If the test button is released before the end of the test cycle, the audio warnings increase in volume. You will recall that to prevent a too low flaps warning when making an approach without landing flaps extension, the flap override switch should be selected. Note that Mode 2A also changes to Mode 2B when the flap override switch is used. A GPWS fault light on the general switch panel indicates that the system has failed. All ground proximity warnings are inhibited when the system is switched off. The ground proximity warning system monitors the flight path and position of the aircraft relative to the ground and alerts pilots to potentially dangerous situations. The controls on the captain's instrument panel comprise a test button, a flap override switch, and a glide slope warning inhibit button. On the overhead panel general switch panel is the fault light and system off push button. The indicators for the system are located on both sides of the main instrument panel. The operation of the test button initiates a system test, and this illuminates the warning lights and activates some of the audio warnings.
Wide slope. Wide slope. Whoa, up. Whoa, up. Whoa, up. Whoa, up.
The table summarizes the ground proximity warning system annunciations and warnings. The altitude alerting system is a function of selections made at the flight mode panel. It detects when the aircraft is approaching a selected altitude from either above or below, or when the flight path deviates from the selected altitude. The only input to the system is an altitude signal from either the captain's altimeter or the first officer's altimeter, depending on source selection. The only control is the altitude select knob. The display shows the selected altitude in feet. Clockwise rotation of the select knob increases the altitude value. Rotating the knob anti-clockwise decreases the altitude value. Deviations of more than 250 feet from a selected altitude causes the altitude alert caption to illuminate on the central annunciator panel and a level 2 alert. When approaching a selected altitude for more than 1,000 feet above or below, a C chord sounds as the 1,000 feet to go point is crossed. When the flight mode panel is first powered up, the altitude display window presents 3 dashes. When an altitude is selected, the dashes are replaced by an altitude value. Turn the altitude knob to find the minimum altitude value. The minimum value that can be selected is 0 feet. Now turn the altitude knob to find the maximum value. The maximum selectable altitude value is 50,000 feet. The knob is geared so that turning it slowly gives a slow change in altitude value. The altitude changes in units of 100 feet. If the knob is turned rapidly, the value changes at a much accelerated rate. When the aircraft approaches the selected altitude from more than 1,000 feet above or below, a C chord sounds in the flight deck 1,000 feet prior to achieving the selected altitude. If the aircraft deviates from the selected altitude by more than 250 feet, a level 2 alert is presented and the altitude alert caption illuminates. The altitude alert caption remains illuminated until the aircraft is within 250 feet of the current selected altitude or a new altitude is selected. The altitude entry alert is inhibited while a new altitude is being selected at the flight mode panel and after glide slope capture. During takeoff, the integrated alerting unit suppresses a number of alerts, including the altitude entry. The two air traffic control transponders installed in the Fokker 50 comprise two antennas under the forward fuselage, two transponders in the avionics rack, and two control panels on the pedestal. The transponder system receives interrogation signals from ground radar stations and replies to the ground with an identification signal and aircraft altitude. The identification signal enables air traffic control to identify specific aircraft on radar. The altitude information is obtained from ADC-1 or ADC-2. Interference between the transponder and DME, which operates on a similar frequency, is prevented by a suppression signal. This is sent from the transponder to the DME when it transmits. The two transponder control units are located at the rear of the pedestal on the right-hand side. Only one transponder can be used at a time due to an interlock system. The transponder control panel has a code display, an identification button, a function select knob, and two code select knobs. The function knob has 6 positions. In the off position, power is removed from the system. In the test position, the transponder system carries out an internal test. When turned to standby, the system is operational, but the transmitter is not active. In the on position, the system is fully operational and transmits the aircraft identification to the ground. When altitude is selected, the transmitter sends the aircraft altitude to the ground in addition to the identification signal. The VFR position automatically selects and transmits the preset VFR code and altitude. The two concentric code select knobs select the aircraft identification code. The ID button is pressed on request from air traffic control, and this causes the transponder to transmit a special identification signal. What is the source of the altitude information that is used by the transponder system? Please touch the highlight. Yes. The transponder is not operating. Before use, it should be tested. Select the test function. The upper part shows the ATC code, and the lower part shows the altitude from either ADC-1 or ADC-2. A fail annunciation is displayed if the transponder is unserviceable. Now switch the transponder to standby. When standby is selected, the system is operational with the exception of the transmitter. The code that was last used is displayed. The ACT in the display and the figure 1 show that the transponder is active. If the aircraft had a double transponder installation, only the active transponder would show ACT and the figure would be 1 or 2 depending on which system was selected. Select a new transponder code. Please touch the highlighted area. The inner of the 2 concentric knobs alters the last 2 displayed digits. The outer knob alters the first 2 digits of the code. When the function knob is selected to on, power is made available to the transmitter. The ID annunciation appears only when the transmitter is operating, which occurs when the transponder is replying to a ground interrogation. Altitude information is not transmitted at the on position. When the altitude position of the function knob is selected, the transponder transmits aircraft altitude to the ground in addition to the aircraft identification code. Select the transponder to VFR. Please touch the highlighted area. With the function switch in the VFR position, the transponder automatically selects a preset VFR code, in this case 1200. Altitude is transmitted with this code. Note that after changing a code, the new code is not transmitted for 3 seconds. The ACT annunciator is not present during the 3-second pause before the new code becomes active. If one of the 3 emergency codes of 7500, 7600 or 7700 are selected, the display will flash for 3 seconds. The purpose of the flashing is to draw the pilot's attention to the display in case of an incorrect code selection. If the spring-loaded ID button is pressed briefly, the transponder sends a modified code to the ground. The use of this button is at the request of air traffic control. The modified code is transmitted for only 20 seconds, and during this period, the identification code is displayed continuously. The container of the flight data recorder is sealed and resistant to fire. It is painted orange and has fluorescent white stripes to assist identification at the scene of a crash. On the end of the container is a water-activated underwater locator beacon. The internal test equipment constantly checks both the data acquisition unit and the recorder. If a fault is detected in either one, a Level 1 alert is generated and the flight recorder fault light on the avionics panel illuminates. The function of the flight data entry panel is to supply the flight data recording system with flight number and date information. The panel is located on the overhead panel. The panel has controls which allow the loading of the following information into the system: the date, the flight number, and time identity marks. Now enter the time identity mark into the system. Please touch the highlighted area. The event enunciation indicates that the time identity mark has been transcribed. The flight data recording system includes a quick access recorder, QAR, activated by the CVR QAR ground control push button on the general switching panel. The QAR records information from the flight data acquisition unit on a non-endless tape. Operation of the QAR prior to engine start is obtained by pressing the CVR QAR push button. Pre-engine start operation is indicated by an on light in the push button. The light extinguishes as soon as either fuel lever is opened. The flight data acquisition unit collects data from various aircraft systems. These signals are processed into the correct form and passed on to the flight data recorder. The acquisition unit is powered by 28 volts DC. Power to the recorder is switched by two sources. The recorder operates when either fuel lever is opened or the ground flight switch is in the flight position. The recorder therefore stores aircraft data whenever the engines are running and at all times in the air. You will recall that system faults or failure are enunciated on the avionics panel. You will recall that the aircraft primary flight and navigation systems include air data, attitude and heading reference system, radio navigation, and radio altimeter. In addition to the primary navigation equipment, the Fokker 50 is equipped with a weather radar, an altitude alerting system, a ground proximity warning system, and two air traffic transponders. Flight and aircraft status data are stored in a flight data recorder. The electronic flight instrument system coordinates the primary flight display and the navigation display. The navigation display can be selected to full, arc or map modes. Between them, the primary flight and navigation system, together with EFIS and the flight and nav systems covered in this module, provide the pilots with all the essential flight information they require.